And we're back. And Josh Dippenaar. Josh, are you with us, sir? How are you this wonderful Tuesday morning?
Good morning, Rob. I am here, I believe, yes.
Yeah, we've got you loud and clear.
Well, thank you.
Fantastic. Josh, as we spoke about, I think we're all very excited to hear what you have to say. I mean, a lot of people are asking the question, what are the impacts of the EVs going to have on our grid? I think George posing some interesting questions about vehicle to grid charging. We're going to hand over to you. I'd just like to remind all our attendees, we do have a live Q&A going, so drop your questions in there and we'll try and pose them to Josh, or I'll pose them to George while he's in studio. And we will try and answer as many of those questions as we can. If we don't get your question, we'll try and answer you privately or individually. But Josh, let me not take up any more of your time. So the people are eager to hear what you have to say. Over to you.
Thanks, Rob. Morning, George. And yeah, I suppose the question of South Africa's electricity grids is a controversial issue and a can of worms. So let's explore this question of what do EVs, electric vehicles, mean for our electricity grids, and what are some useful first steps to start preparing for the uptake of EVs. So I'm from Sustainable Energy Africa. We're a not-for-profit organization supporting municipalities with various things in energy transitions. We've worked with many municipalities around embedded generation or solar PV, and developing the processes and application forms and tariffs and policies for solar PV grid connection. And so that sort of segues really nicely into this field of electric vehicles, because municipalities or grid operators do need to develop a regulatory environment for electric vehicles. It's sort of happening internationally. There's very little happening locally. And so this is the sort of start down that pathway towards electric vehicle regulation environment that obviously tries to enable the uptake of EVs rather than prohibit it. So let's jump in. So I thought of starting with a question: how many EVs do you think there will be in Joburg alone in 2030, which is sort of 8 years' time? There's a few hundred EVs in the city now of Joburg. And just to say that this presentation, I'll be focusing on Joburg, because we are working with the city of Joburg and City Power to prepare for the uptake of EVs in Joburg as part of a UK funded program. So we've developed a forecast of EV uptake in Joburg, and I'll be speaking to that in a moment. But interested to know if people have thoughts. And then what will the impacts of these EVs be on the city's grid? Can the grid handle it? How much electricity demand, additional electricity demand, will there be? And those sort of questions. So I'll look into that. And then finally, this question of what should municipalities do about EVs on their grids, and propose some suggested ways forward. So that's what I'll be covering. Hope it's interesting. So as sort of Carol said, that was really interesting to hear the background of EVs in South Africa, and this is looking much more forward. So it sort of builds on Carol's presentation quite well. But as he said, the uptake of EVs in different vehicle types, or the expected uptake, does vary by vehicle type, depending on things like price trends, the model availability, and national and local policy. So these drivers influence which vehicle types have a good business case for electrification. And so in this truck and light load buckies and truck segment, we expecting, and it's as international trends are showing, a slow EV uptake. This is because of the large range, the distances that they travel, and the heavy loads that they carry does not suit electrification at this point in time. It may in the future, hence the slow EV uptake. Buses and minibuses receiving considerable local policy support. There's a real interest to try and electrify this segment. As Carol was saying, the minibus segment offers an exciting opportunity for electrification. So there we expect sort of medium EV uptake. And then in the cars and motorcycles, the smaller, lighter cars with less, with shorter ranges, fast and rapid EV uptake. So that's what this the numbers by 2030 was built on. And just to say that across all segments, battery price is a driver of initial cost. So obviously, when batteries get cheaper, EVs get more viable, in a nutshell. So I thought just to show one slide of global EV sales. And I saw this recently. I think it came out of an IEA, International Energy Agency's report, or no, it's here in Bloomberg. This red line shows the percentage of global passenger vehicle sales that are electric. And by the end of 2021, end of last year, EVs were 10% of global passenger vehicle sales. So 1 in 10 cars was electric already, which is a crazy uptake. And so I think just with that framing, to bear that in mind, that this uptake is rapid. And when we look at what we're expecting in Joburg, it's built on the premise that these international trends will penetrate the local market. So moving on to this EV forecast in the city of Joburg, we built, a colleague of mine, Zani, built a really robust model to look at how many vehicles we expect by 2030, which is around here, 2040, and then into 2050. And here are the vehicle numbers. So the headline takeaways are that by 2030, we expect 40,000 EVs in Joburg. I mean, it's definitely not going to be 40,000. We know this number is wrong, as are all forecasts, but it's an indicative idea. And I hope we can, at the 2030 EMCA, reflect on how many EVs there are in Joburg by this year. And yeah, 40,000 is a significant number of electric vehicles in Joburg alone in 8 years' time, coming off of the sort of 300 to 400 that there are there today, maybe 500. And by 2050, which is obviously 28 years in the future, EVs are half of Joburg's total vehicle population. Now obviously very difficult to forecast to 2050, but what it's pointing towards is this exponential uptake of electric vehicles in Johannesburg and in the country too. So the question is, what does this mean for the grid? Can Joburg's grid handle these numbers? And what additional electricity demand can we expect? And what should municipalities and electricity utilities start thinking about? So translating those vehicle numbers, so 40,000 by 2030 and then over 1 million by 2050, that converts to an 8% increase in electricity demand by 2050. So this is off of Joburg's existing electricity demand, 8% additional from EV. So I don't know if that's the number that people had in mind when we first came up with this, and we obviously used EV's efficiency, efficiency numbers, electricity demand, kilowatt hours per kilometer traveled, and then converted it into a terawatt hour demand. I was quite surprised to hear that it's only an 8% additional electricity demand when half of every second car in Joburg is electric. So I think the point is that there's sort of twofold. The existing electricity demand in cities and the country is high. So the additional EV demand is not substantial on a system-wide level because of the vehicle's efficiency. So from a generation standpoint, and I think Eskom sentiments are the same, EVs are not a concern from a generation standpoint. The additional demand is manageable. But where the issue comes is to transport that 8%, that electricity, to the chargers. So in the transmission or in the distribution grid rather. So there'll be these pockets of EV uptake in areas like Sandton or the wealthier parts of the country where we expect most of that 8% to be. And that's where the issue comes, is on those distribution feeders to get down to those low voltage networks to transport the electricity. So so by 2050 EVs, it's a sort of 3 terawatt hour increase in electricity demand. And of course, that's a huge additional revenue stream for municipalities, but significant additional work to get and processes and infrastructure to get this 8% sold. So it is definitely a transition of note. So to sort of get a sense of where these hotspots of EV uptake will be on Joburg's network, again, we looked at the wards, the census data for the wards in Joburg, and these colors represent the different expected EV uptake per ward. So based on the existing vehicle ownership in a ward and the income bracket, the living standard measure of that ward, we spatialized that EV uptake. So those 40,000 by 2030, we spatialized them into Joburg to see where are the pockets of where are the hotspots of EV uptake, and what's the grid's condition like in those areas? Can the grid handle that additional uptake? So that red circle there's the sort of zoomed in magnifying glass of it. You can see these red areas are where we expect sort of 5 or 4.5 to 5,000 megawatt hours additional load per year. And the question then is, can the substations feeding those areas handle that additional load? And these pink lines show the substation feeder geography. So this substation here is an example in Bryanston, and the Bryn North substation can expect a substantial additional load. And I don't have the figure in here, but we have those substations existing loading today, and then we sort of get a sense of what do EVs mean for those substations. And of course, let me not give the story away. We'll keep going. But just to say, as the first sort of point is where EVs charge matters. So when an EV is charging on a constrained section of the network, it can overwhelm that network and sort of impact the infrastructure. And so there's this concept that the more public charging we have, the better for the low voltage network. So if municipalities can incentivize electric vehicle owners to charge at work and at the malls when they shop, that's much sort of the network is much stronger there, and the capacity for additional load is much higher. So that's the first sort of takeaway point that I'm making, is that more public charging on MV networks reduces the charging on the low voltage networks where we have these constraints. So in a nutshell, where EVs charge matters. And I think municipalities will need to develop sort of incentives for EV chargers to connect in areas where they have capacity on their network. And then just to zoom into the impact of EVs on the household load a little bit more. We're saying that EVs will impact the feeders in these low voltage networks. And just to sort of illustrate that point, I show here's a sort of a house plugged in with an EV, and there's solar. You can see there's solar panels on the roof. So an affluent household, they've got solar, they've got an electric vehicle. I pulled this load profile off of a friend and colleague in the US who has a EV and who has solar on their roof. So on the y-axis here, you can see the house is the kilowatt demand, so the power electricity demand. And then on the what did I say, on the y-axis, on the x-axis, we have the hour of the day. So this is midnight, and then over here is midnight again. So this, you can see there's a huge electricity demand here from midnight to sort of just after 7 a.m. And then it drops off, and then here you've got the red shows the normal house's demand, and then in the evening, the house's demand picks up again as the house cooks and showers and uses electricity. So this 7 or 8 kilowatt here is a Tesla charging from empty to full. So again, that's worst case scenario. It's from empty to full. So it's sort of almost 100 kilowatt hours. 74 kilowatt hours is huge of demand into that vehicle. And you can see how the EV, when charging at 7 kilowatts or 8 kilowatts, dwarfs the house's demand. So the networks were designed with this in mind. This is what our low voltage networks were designed with in mind. They have diversity factors, and they assume based on people's income brackets how much they'll consume. And now we've got this additional demand on the grid. So it is a concern for the grid, and unmanaged charging of electric vehicles will have an impact on the grid. So the point here is to say, I'll just keep going. So here I've put in Johannesburg's citywide electricity demand in a winter day. So again, that same graph from midnight to sort of midnight. And I think, as Carl was showing in one graph, you see the morning hours, the city's green, this green line, the city's demand picks up through the day, it drops off again, and in the evening people start cooking, and you have that spike in demand again. So when I think Carl made the same point that when people get home from work and charge, as this blue line shows here, this is dumb charging. As the people get home, you can see it's dumb charging exacerbates peak load. So as I showed in that previous graph, that huge additional load, 7 kilowatts, if everyone's charging at peak, which the network is designed for, it can really exacerbate the network's peak, which will have an impact on the grid. So the point is that when EVs charge matter, and ideally we want them charging in these nighttime hours. So we'll look at how municipalities can incentivize that in a bit. To sort of illustrate on this point of when EVs charge matters, I'm doing sort of part-time research at Stellenbosch University, and they have released this fantastic study of their power systems research group to look at the hosting capacity of the network. So this hosting capacity is a concept of sort of what percentage of households can have an EV before the grid gets constrained. So here is the hours of the day from 7 p.m. through the night to 7 a.m. And then up here is the percentage hosting capacity. So if we just look at the orange bars for now, ignore the blue ones. The orange one is saying households, that HH is household. So what percentage of households can have an EV and charge at this time of day? So at 7 p.m., less than 10% of households can charge an EV before exceeding the grid's parameters. Now, these studies are done on sort of detailed load flow analysis to look at the voltage rise or voltage drop and feeder capacity and thermal loading and all sort of parameters of distribution grids. And so the first parameter to be exceeded is exceeded before 10% of households have an EV. As you sort of go later in the evening, as traditional households start using less electricity, at 10 o'clock, almost 30% of households can have an EV in charge. And from midnight, it's 100% of households can have an EV in charge, because obviously people have stopped cooking, ovens are off, stoves are off, heaters are off, geysers are warm again. And so the load on the network is low. So from midnight to 6 a.m. on this feeder, which was a Cape Town feeder, 100% of the households can have an EV and charge between midnight and 6 a.m. So the point is that we need to manage when EVs charge, I think, as you've said, Rob. And so we need to develop this smart or managed charging architecture. And so this is where it gets really interesting. We know we need to do that. I think everyone agrees, EV owners, EV manufacturers, I think industry and municipalities and government, everyone knows that we need electric vehicles to charge from midnight to 6 o'clock in the morning or sometime at night. The question is, how do we get that to be done? Municipalities, if we look at what's happened with solar PV, municipalities have put regulations in place, and customers have, many customers have avoided registering their systems. And I know the reasons are valid. Municipalities often are bureaucratic places, and the process, the application processing times are slow, etc. But to avoid overwhelming the grid, something does need to be done. So there's this. I've created this sort of trade-off chart here to say there's a grid integrity risk. So the higher the risk, the higher the grid integrity risk, the bigger the chance of the grid being overwhelmed and us sort of destroying infrastructure and then having to replace this costly infrastructure and ultimately increase electricity tariffs for all. So high grid integrity risk is not good. But then let's trade that off with customer satisfaction. Obviously, customers must be satisfied. So high customer satisfaction is good. So the first sort of EV management option or lack of a management option is this dumb charging concept. I think Carl mentioned it. EV owners get home from work, 5 p.m., plug in their cars. Cars are charged full by 8 p.m. That's dumb charging because it's not managed at all. So the grid integrity risk is high. There's a huge chance of overwhelming the grid. We saw that less than 10% of households can have an EV and charge before the hosting capacity of the network is exceeded. So the grid integrity risk is high, but the customer satisfaction is high because customers don't have to worry. They can get home from work, they can plug in their car, their car is charged by 8 p.m. They're happy. They don't have to think about anything. They don't have to register their car with the municipalities. They don't have to install a smart charging device, but obviously it comes at the cost of overwhelming the grid. On the other extreme of the spectrum, we have rigid EV charger limits. So similar to with solar PV, you can only install a certain size of solar PV depending on your circuit breaker size of your house. So if you have a 60 amp connection to the grid, you can only install a 3.8 or 3.6 kilowatt solar PV system. And that is a sort of rigid solar PV limit. Now, if we wanted to impose something similar for electric vehicle chargers, we'd say you've only got a 60 amp connection to the grid. You may only install a 2 kilowatt charger or something along those lines. I think that's a terrible idea, but it's still an outcome that could be pursued. Obviously, if that's the situation, your grid integrity risk is low because we make sure that every EV installed does not overwhelm the grid, but your customer satisfaction is very low. Obviously, customers are not going to be happy with 2 kilowatt chargers because they want to charge their cars as quickly as possible. Again, they have to apply for application to the municipality or whatever the outcome is. So I think this is an outcome which we want to avoid as much as this is an outcome which we want to avoid. So let's look for something somewhere in the middle. There could be something along the lines of a mandatory controlled charging. So, we have our geysers have ripple control. So if the municipality is sort of starting to see overwhelm on certain parts of the network, they could send out a ripple signal in their alternating current and they could switch all EV chargers off. So it's a sort of a mandatory control charging. So when you install an EV charger, maybe you have to install a ripple receiver on your charger. And so it sort of protects the grid integrity somewhat. Your customer satisfaction, I think, is questionable. It's quite low because what if you need to take, someone to school in a few hours time, but your EV charge has been rippled and it's now off. So I think that's somewhere in the middle, and it's definitely better than rigid limits, but your customer satisfaction is still low. What if we look at something along the lines of sort of incentives? So an EV time of use tariff. So a tariff that varies, it's expensive in the evening time when we don't want people to charge, but it's cheap at nighttime when we do want electric vehicles to charge. The problem with time of use tariffs is that it's an incentive. So there's nothing preventing wealthy people from still charging their vehicle at 5 p.m. If they're happy to pay, they don't really care about the additional few $100 that they'll pay a month. Then they can go ahead and still charge during these peak times. So your grid integrity risk is still high because there's nothing limiting them from charging. It's no sort of physical limit. So it's better than dumb charging for the grid because most people will probably shift their load into off-peak. And I think the bigger the differential between your peak and your off-peak prices, the bigger the chance of people shifting their load into off-peak. But implementing time of use tariffs for electric vehicles does have its own challenges. I think I've had discussions around the metering infrastructure required and what is the incentive for EV owners that are on a normal tariff to come to you and be put across onto this time of use tariff? Like what's the incentive for? Why would they come forward? Because they're still going to cook and shower at 5 and 6 p.m. in the evening. So if you're going to make their peak time electricity more expensive, then all their peak time consumption is more expensive because they're cooking and showering at 5 p.m. and now that's triple the price that it was before. So there's a question of, is it going to be a mandatory time of use tariff? I don't know. I think it's interesting to explore. I'm also just opening up more questions than proposing solutions here because I think it is a complex space and we know what we want to avoid, these hard regulations. But and we want to move towards something along the lines of sort of incentive-based regulation and schemes to get behavior to move into the off-peak, but there are also challenges in implementing that. So I guess it's maybe ending with a bit of a dream, but I think we can make it reality. It's this kind of concept of collaborative smart charging, and obviously it's the point where customer satisfaction is high and grid integrity risk is low. So your grid operators, your municipalities are satisfied that their grid won't be overwhelmed, and your customers are happy that their vehicles are being charged in a smart way. And so to develop this sort of collaborative smart charging architecture, we need municipalities as well as industry and EV owners to be willing to work with grid operators to try and develop the smart charging architecture. And obviously, there'll be communication with EVs to say, if you can stop charging now, please do, because the grid is starting to be overwhelmed. But those EVs that have an urgent trip, those vehicles that have an urgent trip to the hospital or school or whatever's coming up, they continue to charge and the other ones switch off. So it's all done sort of in a smart device-to-device communication manner. And I think definitely backed with time of use tariffs to incentivize that shift, and things like critical peak pricing. So in really constrained times of the year, we can push the price up to quite a high price to say, everyone that can stop charging now, please do. So I think I don't think it's sort of a defined way forward, but it's this point that we all know we want to achieve of a collaborative smart charging architecture. So I think just to wrap up, I think the first point is that rapid EV uptake can overwhelm distribution grids. I think there's little doubt that is a potential outcome if nothing is done. And the second point that we made was where EVs charge matters. So we want to try and incentivize at work or public charging to reduce the load on the constrained low voltage networks. So office parks and universities and can try and incentivize people to charge at work to try and avoid them charging at home. And at work during the day is obviously great. It aligns with solar generation. The third point is when EVs charge matters. So both where and when they charge matters. And this when point is what we were speaking about, to try and shift the load into the nighttime hours, off-peak charging. And how to do that is the question. And obviously, the sort of final point was that this collaborative smart charging infrastructure must be developed. And so we need people to industry and municipalities and to come together and start developing this before we overwhelm our distribution grids. Thankfully, we do have some time, and EV uptake, while it will be rapid, it's still slow at this stage. So it's a good time to start doing that immediately. Thanks, Rob and team and everyone. Hopefully that was useful.
Awesome, Josh. I mean, I think a great presentation. I've got a flood of questions here. Just a reminder to our attendees, if they want to ask a question, jump on the Q&A and go for it. I'm going to go with one, George, and then I know you've got a couple. Do you think, Josh, that municipalities are going to start pushing for time of use pricing to incentivize solar and midnight charging where we're not at our peak? Do you think that a lot of municipalities are going to start pushing towards this incentivization model?
I mean, I don't know if I think it's difficult to speak on behalf of them. I think they should, definitely. I mean, we're trying to encourage municipalities to do that because time of use tariff is obviously most cost reflective and reflects the price at which they're purchasing electricity from Eskom. So, cost reflective tariffs is the ideal outcome, and we definitely want to move towards time of use pricing to try and reduce peak demand and to try and encourage batteries to charge at night, as you're saying, and to try and encourage customers to use electricity during the daytime when solar is generating. So I think time of use tariffs is a desirable outcome, but implementing it, there are challenges. Meters need to be replaced that can measure electricity consumption on a time of use basis, and municipal billing systems need to be updated to account for the time of use tariff. So in capacity constrained municipalities, which is our reality, implementing time of use tariffs has proved challenging. And obviously there's also the factor that customer backlash and pushback is commonplace. Customers don't like change. They like to stay on the existing tariffs. They don't want change. So I think I hope that we move towards time of use tariffs. There are these challenges that need to be done, but I think with sort of improved communication between municipalities and their customer base to try and sort of encourage customers about the benefits of time of use tariffs, then we can move towards that. Yeah.
Fantastic. I'm going to hand over to George. I know he's got a couple of questions. He has a similar graph for his charging of his EV at home, so he can speak from real world experience.
That was fascinating, Josh. Thank you very much. It was very insightful, and again a lot of data. And I'm so excited that things like this are happening in South Africa, and we've got guys like you that are digging into those levels of data. But from my practical experience in driving the Jaguar I-Pace and having off-grid solar in my house, and then doing long trips, a couple of things that I've noticed over time, and that is, first of all, at my house, I know Carl said it was R2 a kilowatt hour, but I pay typically closer to about R2.30 per kilowatt hour from Eskom, and that is if I need to dip into the grid. But when I go on a long trip, the faster the charger, the more expensive the charge becomes, and that's how the charging infrastructure providers have built the system. Now they're a business, obviously they've got to make money, and this is the way they do it. Right up to about R4.50 to R5.50 per kilowatt hour. So is it really kind of like is it doable to be able to encourage, from a price point of view, people to use public chargers, given that businesses that install the public infrastructure need to also be businesses and make a profit?
Yeah, I don't know the business model of public chargers so well, but we have had a look at Joburg's tariffs, and as you say, the faster they charge, the higher the maximum demand that they pull from the grid, and municipalities have these demand charges which increase depending on your demand from the grid. So sort of the thickness of the pipe metaphor, the thicker the pipe, the power that you need, the more you pay for that thickness. And so I think there are things that municipalities or utilities can do to try and incentivize public charging, and things like reducing this demand charge for EV charging customers, so that you can have these 300 kVA charges that don't get whacked with the 300 kVA demand charge is an exciting first step that municipalities can do. But then equally, I think maybe the prices are so high at the moment, George. My view is because there's such low utilization. I don't know, I'm sure we'll hear from the grid cars people later or tomorrow why they sort of at R4.55 a kilowatt hour. I think it's because they sell so few kilowatt hours at those locations. So hopefully, as we get more EVs and more people start charging, we get economies of scale, and sort of the price of public charging can come down. But I think what the public charging that we also sort of incentivizing or encouraging is this at work charging. I think there's a really exciting opportunity there, is because people tend to go to work most days, and many office parks and have solar PV on the roof. So I think there's also been some exciting research out of Stellenbosch looking at the business case or the potential for at work solar charging, and it does look quite viable. And there's interesting things that businesses can do, such as offer free charging to their employees, and as a sort of additional bonus in addition to the salary. And obviously we know that there's tax incentives on solar, and so when it's done through a business, it can be made quite viable to have solar and an EV charger. But yeah, I completely agree with you that it's not very viable at the moment to charge at public chargers, because it's R4-5 a kilowatt hour, whereas at home it's R2.30 from the grid, or if you're charging from your solar, it's 80-90 cents, R1. So at the moment, home charging makes more sense, but the point is to try and encourage that public charging on the higher voltage networks. Yeah.
So I suppose that that economies of scale point that Josh raises is really, there has to be a crossover, at which point economies of scale take over, and we have this reduction in load at home and an increasing load at public charging stations. And there's a whole nother concept around townhouses. So most people in South Africa live in developments that are on top of each other.
Yeah, 2 or 3 stacks.
2 or 3 stacks, exactly. And and maybe there's an opportunity to incentivize, there's 3-phase, high voltage to those particular developments. You can't tell me that those developments are on single phase. Maybe there's an opportunity there.
Perfect. Now, Josh, I've got a couple of questions coming through from guys. Firstly, a lot of people saying great presentation, so thank you very much for that. A couple of questions asking around the upgrading of infrastructure with the municipalities. Obviously, I mean, costs there. I think how long is a piece of string there? I mean, the cost could be whatever the cost could be. What kind of timeline do you anticipate we're going to be seeing municipalities, especially the big metros, where you have said we anticipate the uptake of EVs being more? What kind of timelines are we looking at for infrastructure to be upgraded? Because as you mentioned, Sandton, let's say suddenly 100 EVs are bought in Sandton, Joburg's going to have to look at upgrading that infrastructure because there's going to be a massive pull on that local infrastructure. What kind of timelines do you think we're looking at? Are we looking at a similar timeline in terms of the rate of adoption of EVs being 10, 15, 20 years? What are we looking at there?
Yeah, Rob, that's such a tricky question, and
that's why I posed it to you, Josh. You're the expert.
Yeah, no, I mean, I think it's difficult to know because it depends on the maintenance on that infrastructure as well as the EV uptake. And I think what we're sort of saying broadly is that in the next 3 to 5 years, it's not an issue, but we need to start planning with urgency to avoid it. So, I mean, it's not to say that in 5 years, all of a sudden, substations are going to start being overloaded. We don't know that, but for this, in the short term, it shouldn't be an issue, and we can start putting in place these smart chargers to try and shift that load off peak. And as some of those hosting capacities were saying, ideally we don't overwhelm that infrastructure, because if charging is done correctly and smart and managed, then 100% of households, okay, that was one single feeder. We need to do much more of these studies on more feeders to make sure to sort of before we draw generalized conclusions. But just from that one study, it shows that there's hope in potentially not overwhelming that infrastructure.
Josh, before we could go for our tea break, I think George has got one more question for you, one more point you'd like to ask you, and then we're going to jump to a quick comfort break before our next session.
So, Josh, I mean, I don't know whether you've dug into this at all, and it might be kind of left field question, but many homes in South Africa have prepaid meters. How does that affect the the principles that you lay out? Because those prepaid meters are you literally buy electricity at a predetermined tariff. I mean, I know I've got a prepaid meter at home, which I don't use very often. And then that electricity gets used over time. So how do you, as a municipality, begin to think about time and cost to use at different times of the day and night when we have such a big prepaid environment in South Africa?
Yeah, I think you've raised the major issue in moving towards sort of tariff modernization or time of use tariffs is the metering, and customers are now getting used to this prepaid metering, and there's a huge drive from the municipalities to move customers onto prepaid meters because they then benefit from reduced non-payment. So customers obviously pay up front and then you only get units that you paid for. Whereas with conventional meters, you can use a few months of electricity and not pay before they'll cut off your supply. So prepayment is desired from the municipality's perspective, but how do we marry that then with time of use tariffs and the smart charging that we're proposing and that we really need? So I think that's the major hurdle. And there are some exciting ideas. There are smart prepayment meters that can handle time of use tariffs. So you buy and you get a whole lot of tokens, or you get rand value on your meter, and as you draw electricity at different times of day, it sort of deducts credits at a different price. So it's sort of time of use smart prepayment meter. I know some companies are bringing those out. Alternative ideas internationally in the UK, I know they have separate meters for the house and the EV. So the electric vehicle has its own electricity meter, and the electricity vehicle has its separate tariff. So it's got an EV tariff, and the house has a separate tariff that it pays. So to try and separate the load, the house load and the EV load, that's a different idea. There's not much thinking around doing that locally. It's all sort of around the single meter at this stage in South Africa, but that's happened internationally. So there are ways forward, but you raise the major challenges that need to be overcome. And maybe just the last challenge is obviously that customers resist change. Customers get used to this prepayment story and want to stay on that. So I think I mentioned it earlier, municipalities need to sort of communicate well with their customers to sensitize them and show them the value of moving across to these new tariffs.
Fantastic, Josh. Well, I mean, we've got a lot of questions for you. Obviously, your presentation has struck a chord with a lot of people. I think it's people are asking these questions before they go and invest in an EV. But we're going to have to love and leave you. Thank you very much for your time, and it's been a pleasure having you join us with us. For EMCSA 2022 this year. Thank you very much, Josh.
Cheers, Robin. Cheers, everyone. Thank you very much.